Yeah, so a very good afternoon to all of you. Uh, Very good afternoon, Nisa. I think it's a time, so we can start our discussion today. And now, Gitu, blank paper. So right now we are in the week 8 of this particular course, and this is the last week. And today's will be the last interaction session in this particular dot solving sessions. Okay. So in the week 8, let's see the what are the content that has been covered in this particular course. So here we discussed about the traditional type of the carbon that has been available to us. That is the most important is the graphite and diamond. Then we discussed about the hard carbon and soft carbon. We also discussed about the structure of the carbon nanotube, that is CNTs, that is armchair and multi-wall, single-wall carbon nanotube. Those things had been discussed. Then we also discussed about the nomenclature of the CNT, that is M, N. How we define those things. Okay, so these are the factors. Then we At the last video was entirely based upon the graphene, and we discussed about the graphene to a very large extent. And so what we'll do, we'll try to solve few questions based on them. In assignment also, you can find the questions to be little bit tricky. So we'll try to solve the similar type of questions, and so that will be helpful for you guys. Okay. So before we start to the solving the questions, let me ask you that if you guys have any doubt in this uh, week, week 8, or from week 1 to week 8, please let me know. You can always put your question on the comment box. Since there is no question, so let's move to the next. Let's move to the question number 1. So here is a question number 1. You will find the exactly same type of question in the assignment. I think question number 2 that will be. It's not exactly same. It's a little bit different from that. Let's try to see that how we can find. So chiral indices are given to us. Let us say first one is a 4 comma 0, 4 4, and 4 2. We need to find whether it is a chiral, zigzag, or armchair type. Okay, that is a question. So let's start with the question number 1, that is a 4 comma 0. See, what is a zigzag? So we'll get something like this type of pattern. While in the armchair, we'll get something like this. Okay, so on and so forth. So while in the chiral will not get any particular of this and this. It will be something combination of both of them. So let's try to solve the question number 1, that is 4 comma 0. To find the 4 comma 0, we have to select the origin first. Let me select the origin somewhere over here. Okay, this one will do. This is 0 comma 0. Now we have to select the lattice. Okay, we are moving in the some particular directions. So I can select. So we'll not select any other point. Okay, we'll not select points such as this and that because they are not contributing toward the lattice point. Lattice point over here are only these things, and then again we'll leave one of the atom and then we'll go some other point. We'll leave one atom, then over here. From here we'll leave this atom. We'll go to over here. So all the alternate atoms will take. Okay, and they will form our lattice. Now let's select the vector. Okay, that is a1 and a2. If I complete this particular hexagon, it will be something like this. Okay, we'll get one more point over here. Armchair, zigzag, and chiral. So Nisa is telling that the option number 2 is the correct option. Uh, Can you just recheck your answer? Like there is something is not correct over here. So so let's try to solve it together. So what we can do, so this is a point. So let's select one vector is over here, another vector is over here. Let's say this is the a1, this is a2. So the first one is telling that 4 comma 0, it means that in the second direction we are not going anything at all, right? So along a2 we are not going by any amount. In a1 we have to go by the 4. Okay, so 1, 2, 3, and 4. We got to this particular point. Let us say point number 1, that is we can denote it to be the a1. Okay, so this was the a1, and we got it over here. This is a1. So from 0 to a1, let's see how we can go. We can go along this, right? So the first one, 4 comma 0, is something zigzag pattern, so we are following this particular way. So the 4 comma 0 is a zigzag. So the only option which we are able to see is the option B. Okay. Still, I made the question in the wrong way. I should have give more option having the zigzag at the initial part. Still, let's try to solve the 4 comma 4. So 4 comma 4 point we have to take. So we have to move by the 4 in this particular direction also, and along A2 also we have to move by the 4 comma 4. Like along A2 direction we have to move 4. See, we have already moved over here. Let's move along the A2. 1, 2, 3. Okay, I should make one more hexagon somewhere over here. Uh, Let me make it with the black color. And then we arrive over here. So this is our point B or A2. Now how to go from origin to A2? That is, we have to follow this particular vector. How we can go along this? I should select something. We can go along this particular path, following this path. And this is the armchair one, right? So it is following this particular path. So with that, we got to know that this one is the armchair. Okay. Now let me tell you one thing. So we already got the answer that option B is the right answer. Always remember that 4 comma 0. Sorry, if 0 is there at one position, then it will be the always zigzag. And if both the values are equal, then it will be always be the armchair. Okay. So with that, we can solve this question number 1. And 4 comma 2 will always be the combination. So let's look at the point at least where will the a3 will lie. So we move by the amount of 4 in the along the a1 direction, but we have to move in the a2 direction also by the amount of 2. So 1, 2. So we'll get somewhere over here, and it's a chiral one. It's not the armchair or it's not the zigzag pattern. Okay, it won't follow that those things. And so with that, we got the option B to be the right option, and with that, the question number 1 we have solved it. Please let me know if there is any doubt in this question. Question number 1. Okay, since there is no, let's move to the next question. Question number 2. Now this is easy type. If we went through the lecture, will we will easily be able to solve this one. Answer it. What is a D spacing, that is D002, typically used to identify highly ordered graphite? If the graphite sheet is highly ordered, then what will be the value? Option C is the right option. Right. So with that, what about the highly disordered? If we talk about the highly disordered, then what will be the answer? So this is for the highly ordered. You are right. So for highly disordered, will it be higher or lower? All the data is not sufficient enough for us to comment on this. So we have seen in the class that if it is a disordered type, the d-spacing will always be higher than the, like, in general, in the large number of cases, it has been found that d-spacing is higher than the 3.35. So the it will be the disordered one. So if we do the XRD, from the XRD we'll get to know that okay, the d-spacing is comparatively higher, that is along the C direction. So with that, question number 2 is done. Let's move to the next question. Question number 3. Yeah. Select the correct statement regarding the diamond and graphite. Okay. So the first one is that we have to select the right statement. It can be more than one answer will be. It might be possible that more than one answer will be right. The first one is diamond has the cubic packing, while graphite has the hexagonal packing. What do you think? Is first option is a right or correct or incorrect? It's a false. See, diamond is having the cubic packing. That's we know, but the graphite is having the hexagonal packing. So in the layer, within the layer, we can see that it has in the hexagonal packing, right? So instead of graphite, if we use the word graphene over here, that will be the much more correct. But let me tell you, this is also the correct statement. It is also forming the hexagonal packing. So within the layer, it will do like that, and above the layer, this will be expanded, and then again they will form the hexagonal packing. So the first answer is right. The option number one is the correct one. Second one is telling that the diamond has a stronger bond between the carbon atom than the graphite. Uh, is the bonding within the graphite? Let's talk about the interplanar within the plane. Within the plane, this atom spacing. Yes, graphite is stronger, right? So in this case, the graphite is stronger within the plane. If we go above the plane, then the bonding will be, obviously the diamond will be the one which will be higher. Okay, the stronger bond will be in the diamond in that case. But within the plane, if we talk about, I should specify over here within the plane. Okay, so with that, diamond has it. This is a false one, right? So till now we got the answer A to be the right answer. B is wrong. C option. Diamond has the 3D network of bond. Okay. While the graphite has a flat sheet of the bonded carbon atom. Is it true or false? Diamond is having the 3D network of the bonds, while the graphite has the flat sheet of the bonded carbon atom. Uh, so Nisa, what do you think? What is your opinion on this? See, this is the correct that diamond has the 3D network of bond, right? And the graphite has the flat sheet of the bonded carbon atom. So we are having the sheets, and these sheets are stacked on top of each other. Graphite is also 3D. Graphite is also 3D, but this 3D is made up of the multiple layer of the flat sheets. Okay, so like if this is a one sheet, then this is another sheet, and this is another sheet. Keep on going. Okay, so in that way, if we see from this perspective that okay, it is made up of the flat sheet of the graphite. Okay, then it's true. Okay, Diamond has the sp2 hybridization while the graphite has the sp3 hybridization. Option D. So for the option D, is diamond is having the sp2 hybridization, and okay, so it is the incorrect one. Okay, so D is the incorrect. So only option we got is A and C. Okay, yep. So this one is having the sp3 and this one is having the sp2. That's right. Okay, so with that, the question number 3 is done. Let's move to the few more questions. Yeah, over here. What determine the strength of the carbon-carbon bond in the disordered carbon, hard versus soft? So we already got that. Okay, disordered carbon is there. Let me tell you, only one answer is correct over here. It MCQ. The presence of the cross-linking, the number of the layer of the graphite sheet, the type of hybridization, the size and shape of the disorder. Okay, so which is the dominant one over here? Like among all of these, like to certain extent, one can say that okay, all of them are correct. But what do you think? Which one is the one will define more? Which will be the more significant answer over here? So the difference between the hard and soft is, yeah, option A is the one, right? The difference between the hard and soft is coming from the cross-linking itself. If we take a soft material and will increase the cross-linking within that, it will become the hard. Okay. So with that, the question number one, for the question number 4, we got the answer 1 to be the first option is the right answer. See the type of hybridization, sp2, sp3. They both will be having somewhere. Okay. The size and shape of the disordered carbon structure. Okay. This is not the one which is governing. Let's move to the next question. Okay. It's comparatively easier to answer this one. Among all the questions that we have did till now. Interatomic distance between the carbon-carbon in the graphene. If we know the value, that's it. So they are talking about, we are having the graphene sheet, and within that graphene sheet, what is the distance between the carbon-carbon atom? Yes, option B is the right answer. So 1.42 angstrom. We'll remember this particular value because this is going to be quite helpful for us to solve the next few questions. Okay, question number 5 is done. Okay, we have to find the gap between the two walls of the double walled carbon nanotube. Okay, so we are having, let's say this is the one of the carbon nanotube we are having. Across that we are having one more. So there is a two walls over here. The comprising of the 4 inner tube and 11 outer tube. Okay. What we need to find the gap between the two walls. That is, we need to find this distance. This D is missing. So we are aware that we can find the diameter of the any tube if this particular value is given. Okay. If the vector is given to us, scalar vector. So how we can find? We have aware about the formula. Like in the class, it has been derived to the in a much more detail that ACC divided by pi with a root over n square plus m square plus nm. We know this particular thing. And m are this. These are the one 4 and 4. Now We can find the diameter of the internal one. With diameter, we can find the radius also. We can find, using the same formula, we can find the radius of the outer also. Once we got these two things, we will subtract them and we'll get the answer. So let's try to do it. What is a ACC? Subscript C and C. It's in that the carbon-carbon bond length. Okay, and that is something which we got to know, that 1.42 angstrom. Let's try to substitute. See, one thing we are noticing, that 4, 4 and 11, 11. That is a value of N and M. They are same. Let's put those thing in over here, that okay, our N and M are having the same value. So what we'll get? We'll get that the, let me call it to be the AC divided by pi root over n square. This can also be n square and this can also be n square. So we'll get 3 times of n square. So here we'll get n will be common out. AC is there divided by pi and root over 3. So the diameter of the smaller one, let us say the inner one, inner diameter will be A, that is 1.42 multiplied by n is nothing but 4 times root 3 divided by pi. Option D, you are telling that? Okay, let's check that. I think you followed the same thing which I am doing, is it? So for the outer, we can see that it will be 1.42 again multiplied by 11 multiplied by root of 3 and the whole divided by pi. Now we can subtract this two things. See, this is the diameter. Let's make it to be the radius, dividing them by 2 pi, dividing them by 2. Now we can find, we got these particular values. Now we just need to subtract them. Outer minus internal we have to do. So it will come around 1.42 root 3 divided by 2 pi. These things are common. This and that. So the only thing that we need to subtract is 11 and 4 and it will be coming around the 7. Let me use my calculator over here. Remember the unit of this is Armstrong. Okay, I hope it's visible. So 1.42 multiplied by root of 3 and then multiplied by 7 divided by 2 pi. Okay, I think I made some mistake over here. Is it? So what can be? 1.42 is right, root 3. Oh, I made one mistake. This entire thing was having the multiplied by 3. So 3 will root 3 was also there. So this root 3 will be converted to the 3 itself. That was a mistake. So instead of root 3, I should write 3. And with that 4.74 angstrom we are getting. And we can, in nanometer, if we have to write, we'll just use the decimal and it will be 0.474, coming around this. So the option D is the right answer. Yeah, Anissa has also got it right. Okay, so with that, question number 6 is over. Let's move to the next question. Question number 7. Over here. So now here we need to calculate the chiral angle, that is theta. Okay, for this also we have derived to in our class that we can calculate the cos of theta just from the this particular equation. Okay, so knowing the value of m, we can substitute and we can find the respective value of the cos of theta, and from that we can find the theta. So what do you think? Like, let me mark them. Three. Yeah. We just need to substitute this value. Let me substitute the 5 over here. That is, both the values are equal. So in that case, 2n and m will become 3 times of some value n. I'm taking m to be equal to n. Here we'll get 2 root over this. Again, these values will be same. So we'll get 3 times n square. So with that, we can get that the 3n divided by 2 root 3 times n. This will be cancelled out and we'll get root 3 by 2. So 1 is matching with the c. What about 0 and 5? If I put 0 over here, if n equal to 0 and m is equal to the 5, then okay, it's coming to be the 60. Yeah, it's 60. That's right. And 5 comma 0, if I put m to be 0 and n to be the 5, okay, then it's coming to be the 0. So now the only thing remaining is that's this one. So question number 4, it will be coming around the 90. Right. So with that, we have solved this question number 7. So let me know if there is any doubt in this question number 7. All we did, we used this particular formula which we derived in the class. Okay. Since there is no, let's move to the next question, question number 8. Okay. We have to select the correct order for the thermal conductivity. And the questions are the discussion is on the graphene, diamond, and graphite. So, among this, which one is having the higher thermal conductivity, first of all? Graphite, diamond, or graphene? Okay. So, we are aware that among all of them, the graphene is the one which is at the top. Okay. So, the graphene will be having the highest conductivity. Okay. So, Anissa is telling that option C is the right answer. Okay. So, the graphene have the more thermal conductivity, right? Yes, option A is the right answer. What the thermal conductivity depend upon? It depend upon the bondings. Smaller is the bond, easier is it is for the bonds to transfer the energy because the distance is less. The vibration, that is the thermal vibration which will be generated by the heating of the sample, those vibration will be transferred toward the next adjacent atom quite easily due to the lesser bonds. And we know in the graphene, the bond of the graphene is less, okay, is smaller than the diamond. So with that, the option A is the one which is the right answer. Okay, so with that, we have solved this question number 8. Let me know if there is any doubt in this question. Okay, since there is no, let's move to the next question. Question number 9. Select the correct order of thermal conductivity. So now here there are a few additional things which we have not learned in the class. That is, there is a copper is there, NaCl is there, wood is there, and graphene is there. Okay. So among all of them, which one is having the highest thermal conductivity value? First, we let's think about that. And the one which is having the lowest thermal conductivity value. And the reason here we can say that, like, think from the perspective that graphene has the highest, right? So already the answer is clear that the option B is the right answer. But one more thing, from the wood perspective also we can think that why in the hilly areas most of the things are made up of the wood, and the reason behind that is that the heat from within the inside it shouldn't transfer toward the outside, right? That's why we in the if we go to the hilly area side or the colder region, those places will take the wood to build our house. Okay. Then the after wood the salt is coming, NaCl, and then the copper is there, and then the graphene is there. Okay. So with that we have solved this question number 9. Let's move toward the question number 10. So question is telling that which of the following statement among the ability about the ability of the graphene to pass gas through it is true. Okay. So we have the graphene, and which of them is true regarding the passing of the gas through the graphene? Option is telling that all gas atom can pass through the graphene. Only helium atom, the smallest gas atom, can pass through the graphene. Graphene is completely impermeable to all gas atoms. The ability of the gas atom to pass through the graphene depend upon the temperature. Among this, which was the answer that we have learned in the class? Okay, so there was a topic where we learned about the helium gas within this graphene topic. Okay, option B. Okay, only helium atom, the smallest atom, can pass through the graphene. Well, we have learned in the class that even the helium atom itself was not able to pass through the graphene. Okay, so the graphene is impermissible to all the gas atom on an average, mostly. Okay, so we have learned that this particular gas, like there is a carbon over here, and let's say we are passing the helium atom. This will not fit over here. The size is not that sufficient enough to fit that helium over here. The size of the helium is comparatively higher with respect to the void size available over here. It won't be able to pass through it in that way. While if it has been graphite, then we can see that there within the layer it's not possible that, but between the layer, all the helium and all helium, lithium, those things can be passed through it. So the graphite is permissible to all the gases, but graphene is not permissible to all the gases. So the option C is the right answer over here in the question pattern. Okay, let me know if there is any doubt in this question. Okay, since there is no, let's move to the next question, question number 11. We have to do the match the following. Let me tell you, this is the electrical conductivity. We have to match the material with the numbers over here. Okay. See, it is impossible for us to remember any number, the conductivity value. Okay. So the aim of the question is also not like that for you guys to remember the values. It is to which one is the highest one. Okay. Among this, find which one is the highest number is 8. And then among this, find that which one is the highest conductivity, which one is having the more conductivity. Copper, graphite, graphene, platinum. So what do you think? What is your opinion that among the copper, graphite, graphene, and platinum, which one is having the more conductivity? Graphene is the one, right? So we can match the graphene. Okay, sorry, I forgot to write the numbers. So 3 is matching with the first one. Then next value we are having the 6. So now the competition is between the copper, graphite, and platinum. On the copper, graphite, and platinum, which one will be having the more conductivity value? Electrical conductivity. It's the copper, right? So we can match with the copper. Among the graphite and platinum, let's choose one more value again. Okay, let's select this particular value, 0.946. The next one. We are having the graphite, we are having the platinum. Now among these three, which one is having the more conductivity? It's the platinum. Okay. And the graphite is coming somewhere over here. Okay. Just a minute, guys. Okay. Between the platinum and graphite, which was the one? Platinum. Platinum was the highest one. Okay, so we got the order that the copper is first is graphene, then the copper, then the platinum, and the graphene. Let's make one more question based on the similar type of stuff. Let us say we are having the copper. Those things again. So the compared to the stuff which is over here. Oh, we are not talking about the thermal. It's electrical conductivity we are talking about. See, all of here are the top-notch element among the conductivity values. So now let's make few questions based upon the things that one should aware of, even though which has not been discussed in the class. Let's say we are having the copper, gold, silver, platinum, and let's take aluminium also. Let us say we have to arrange them. Okay. Oh, their names are different. So we'll call copper as C, gold as G, silver as L, platinum will be P, and aluminum will be A. So among this, if we have to arrange which one having the more conductivity, which one will be the first one among all of this? The one with having the highest conductivity value. The copper. It was surprising to know that even the silver is the one which is having the more conductivity than copper. Okay. Initially, I was also like telling everyone that okay, it's copper the one, but recently I read one book, and based on that I got to know that it's silver the one. Then, okay, what about the remaining things? Gold, platinum, and aluminium. Who will come after the copper? After the copper, it will be the gold one. Okay, the conductivity of the gold is comparatively higher. and then it will be the then it will be the aluminum, and then it's the platinum. So we can see that the even among all of them, we use the platinum. The platinum is the one which is having the lowest among all of this. Still, you will find that people, whenever they go for the high temperature applications, they will use the platinum. They will not use the other elements. It's because of its nobility, how noble it is. And second thing is that its temperature, oxidation temperature, it's very high. Its melting point is also very high, and that's what make platinum, even though having the low conductivity value than the other things, other elements, still it is useful. Okay, okay. Let's not deviate from our topic. Let's move. So with that, we have solved this question number 11. Let's move to the next question. Question number. But this is our final question we are having. The easiest one. Which of the following statement about the ability of the graphene to pass gas through it is true? Oh, I made it wrong. Which of the following statement about the ability of the graphene with respect to steel and aluminum from the perspective of the density? Okay. So directly we are saying that we are having the graphene, we have the aluminum, and we have the steel. Among them, which one is having the highest density, and which one is having the lowest density? Let's arrange them in the from the perspective of the density of the materials. Steel, aluminum, or graphene. Which one will be the highest? Graphene has the lowest. That's right. Graphene is the lowest one. And then the aluminum will be the comparatively higher than, yes. And then the final will get the steel. I think the value is something around 7 and 2.7, and here it will be around 2. I think so. There might be some error. But with that, I think the best option among these will be graphene is much denser than the both. No, incorrect. Graphene is slightly denser. No, this is also incorrect. Graphene has about the same density as a no. Graphene is less denser than both the steel and aluminum. The option D is the right answer over here. Okay. So with that, we have solved this question number 12. So, so with that, our all the question that I have planned for this particular week is over. Just have a look on all those things. If you find any question to be there is any doubt in any of the question, please let me know. Okay. So if there is any doubt in this particular doubt solving session, or in this particular week 8, or throughout the session that has been covered, like from week 1 to week 8, we can discuss those things if there is any doubt. Okay. This will be our last doubt solving sessions. So before I end, let me give you few recommendations on the book which I followed for this particular entirely course. Meanwhile, you can let me know if there is any question you are having. See, in the initial stage of this particular nano course, our nanotechnology course, we discuss about the tensile test, how the strength of the material will depend on grain size. We talk about the Hall Pitch equations. So in order to study that, I use this particular book on the mechanical metallurgy. So in that you will find the chapter number 8 will be the majorly based on these particular topics. Okay, and this is a well-known book. All the metallurgists and the mechanical people, all those who are working on the material, the strength of the material, They follow this particular book. Okay. Then we have also studied. Could you please explain the first equation again? First question again. Question number one. Okay. Okay. This one question. Right. Let me take one more hexagon. Okay. Let's do this particular question on the nucleus diagram. The chiral indices, right? So first of all, we need to understand few concept over here, and that is that the all the points that has been given to us is not the lattice point. Okay. So for example, if I make a cubic structure, if I'm making a cubic structure, unit cell, okay, lattice point I'm making. So they all of these particular points, they all are the lattice point. We can put in an atom, let us say aluminium, it's fit in the cubic one. Okay. So all the aluminium atoms over here, they are sitting at the lattice point. While over here is all the carbon, this dot which I am representing over here, they all are the carbon. Are all of them are the lattice point? The answer will be the incorrect. All of them are not the lattice point. The reason behind that, let's take about this particular atom, this particular point. Let's take one more atom somewhere over here. Let's take this particular atom. If I move by the amount of this particular distance, let us say this distance is a, I will find one atom. While for the same lattice point, for the different lattice point, if I go by the same direction, by the same amount, I won't find any atoms. So this is not the lattice point if I'm choosing this to be the lattice point. Okay. So here, first we have to select the lattice point which are working for us. While see for the cubic, let us say this is my lattice point. I am moving toward this particular direction by the amount of a. I am taking one more lattice point somewhere else. In the same direction, in the same magnitude, if I move, I will get another lattice point. So these are all the lattice points. So what? So here, what we have to do? The lattice points are only this. We'll not select this as a lattice point. We'll select this as a lattice point. We'll select this as a lattice point. So alternatively, let me mark, and we'll again try to do these things. Okay, let's move by this amount, and whether we are getting the similar surrounding or not. So leaving one of the atom, I'm always selecting the another one. Okay, alternatively. So I will not select this. I will select this one. There is some hotspot over here. So let's make this is my lattice point. Okay. So now let us say I'm having this point. Now I move by the amount of 2a. From here, this is, or let us say by this much amount, whatever it could be. Let's say this, let me tell you that this is a. So this entire distance will be again 2a by geometry we can find. So totally I move by the amount of 3a. And I found one more lattice point over here, equivalent to it. Now let's select this particular point and again move by the same amount. So we'll find that 1a, 2a, 3a. We'll again find that okay, there is a one more lattice point. So with that we got to know that the red one which I mark, those are corresponding toward the lattice point. Now see in the cube we select, if I'm taking a cube, we select a1, A2 and A3 along the three axes. But here also we have to select. Okay. So here it's a two dimension first of all. So we'll select the way by which, see again, this is again the lattice point. So we'll select this vector and we'll select this particular vector. I can find any other vector just by the linear combination of these two vectors. Let us say this is A1 and this is A2. Right. So let us say if I want to find this particular vector, so how will I find? I will say that okay, let's move by the amount of A1, 1, 2, 3. 3 times A1. I find this particular point. Okay. So in similar manner, I can find all the lattice points just by the linear combination of them. Now let's move toward the question. The question is telling where it went. The question is telling that we need to find 4 comma 0 where this one is lying. Okay, the 4 comma 0 is the one which we need to find. So along the first axis, we'll move by the amount of 4. Along the second axis, will not move at all. Let's move along the one of the axis. Let me take this. 1, 2, 3, and 4. We got to this particular point. Okay, starting from 0, we got point A1, which was having the chiral index of 4 comma 0. So this is A1. Now see that how from here to here can I go? Following the, not following this particular path, following this red lines, sorry, this black lines. So I can go like this. So this is somewhat zigzag type, right? Something like this. And so with that we got to know that the point OA1, this vector, is a zigzag one. So 4 comma 0 is over. Till now, is it clear, Anisa? Perfect. So now we need to find the another one, OA2, and that is having the 4 comma 4. See how much distance we move over here? We move by the amount of 4. Now we have to move back by the amount of 4 again in the direction of A2. Okay, the A2 having this particular direction. Okay, so along this, so these directions. 1, 2, 3. I should make few more. Okay. Okay, since there is not much, should I make it over here? Okay, somewhere over here it will be. Okay, so 1, 2, 3, and 4. By this much amount we went. Okay, so somewhere over here we are. So we went by the 4 over here. 1, 2, 3, 4. Again we went and we got to over this particular point. Now from here, from 0, if I want to go to this particular point directly. So this is my OA2. So what I can do, if I want to go along this particular point from 0 to this, from origin to that particular point, how I can go? I can go along this particular paths. So it is somewhat like if I draw it separately, this particular blue pattern which I made, it is going like this. Right. So it is looking like an armchair. And so with that, we can conclude that the option, it is following something like this. So 4 comma 4 is armchair. So the remaining, that is 4 comma 2, will be the, anyway we have got the answer. The 4 comma 2 also we can find. See, we already moved by the 4 amount. Now we have to move by the amount of 2 in the A2 direction. So 1 and 2. So we got this particular point. Now from here, from 0, like from origin, if someone want to go to this particular point, you can try, but there won't we won't be able to find any zigzag or armchair pattern. Solely zigzag or solely armchair pattern. So that's why this will match with the parallel. And based on these things, even if you do for this, like I did for the 4 comma 0 and 4 comma 4, even if you do for the 5 comma 0, 5 comma 5, again you will get that, okay, this one, this entire thing, if there is 0 is present, then it will always be the armchair, sorry, zigzag. One just need the more number of hexagons in the figure. I was not able to get extra hexagon which I was looking for. While here, if both of them are equal, then we'll get the 5 comma, they will get the this armchair type pattern. Okay, and if the values are different, then we'll get the chiral one. Okay, so with that, this is the question number one. Let me know if there is any doubt in this one. Is your doubt clear? Yeah, that's great. Okay, so let me quickly tell you guys that those things, the books which I followed using. So as I already told you about the detail I use for the tensile testing, though the stuff which we have discussed in the class. To large extent, we have also discussed to certain extent about the sintering of the books, sintering of the ceramics, and this book, the sintering I follow usually. So the language here in this particular book is quite tough, but one can go through it, and this is very detailed book. Like if you find any book on ceramics, they will what they will do, they will talk more about the structure of the ceramic phases in the phase diagram they will talk about, and the sintering part will be extremely small. While this particular book totally entirely talk about the sintering of the ceramics. I was telling about the few books will tell you entire fundamentals of the ceramics, and this is the one where you can find the phases, evolution, and those things. Even the nano aspect will be given over here. How the ceramics has been made, how they are processed, and those stuff. And the sintering aspect. See, any beginners is there. If there is any beginner, they should follow for the ceramic. They should follow Barson. So today we discussed little bit about the crystals and all from the perspective of the lattice and motif part. Okay. So if someone want to clear those concepts, there is a book on the crystallography by by Mark de Greve, and they will explain you entirely that when a particular point will be considered as a lattice and when it will not be. Okay, just like we discussed over here in our question, that we were not considering this point to be the lattice. We consider this to be the lattice. And what is the reason behind that? Like in much more detail, those things has been discussed in this book. Okay. So these are the list of the book which I follow. There are the few more, like for the SEM. For the SEM, I follow this particular book, Scanning Electron Microscopy, and you will find in depth the stuff are mentioned over here. That how the images are being formed, what are the challenges that one faced during the SEM while doing the SEM. So this is mostly for the operators are also reading this particular book. Okay. So these are the list of the recommendations on the book from my side in regard to this particular course. Okay. So with that, our doubt solving session and this particular course doubt solving session all are over. I think in the few upcoming weeks, you guys will be having the exam. The exam will not be very tough. Let me tell you that approximately 75% of the questions will be from the assignments and the thing that we have discussed. 25% might here and there it can vary. Okay. Okay, guys. With that, we can end this particular session. Thank you.